To understand the exponent property, we need to remember that a logarithm is an exponent. So for example, if I have x to the second power and I take that to the third power, I multiply those exponents together and I get x to the sixth power. Well, a logarithm is just an exponent. So if we end up taking a logarithm with an exponent, it's like we have a logarithm with, it's like we have an exponent with a power, and we would just multiply those powers together. So here's what that property looks like. For log base b of x to the nth power, so we have a logarithm or an exponent to a power, we can simplify that by just multiplying this power times that power. And to do that, we're going to multiply the m in front, so it becomes like a coefficient of our logarithm. So we have m, one power, times the logarithm, which is the other power. So a power with a power is multiplied together, and the power just becomes the coefficient. So just write that down. Power becomes coefficient. Okay, we're going to use that property to solve a couple of exponential equations. Now, back in 4.1, we learned to solve exponential equations by trying to get the same base. So on this side, we have a 2. On that side, if it had been an 8, we could have changed it to 2 to the third power, and then x would have equaled 3. However, 3 is not a base of 2. Like, there's no way for us to, in our heads, figure out a base of 2 for the number 3, which is where logarithms come into play so that we can find those types of answers. The first thing we're going to do, though, is what I like to call the golden rule of algebra, which says we can do the same thing to both sides. So if we want to do the same thing to both sides and we want logarithms, we can go ahead and take the logarithm of each side. I'm going to go ahead and tell you step by step what I'm doing. So step 1, I'm going to take the log, or ln, either way, because either one can go in our calculator, of both sides. So that's going to turn my equation into log 2 to the x equals log 3. Okay, now I'm going to use the power property. So to use the power property, that means I'm going to take that x that's on the first part and move it in front as a coefficient of log 2. So now we simply have x times log 2 equals log 3. Well, when we solve for x and it's multiplying by something, don't we just divide both sides by that thing that's multiplying? So we are going to divide both sides by log 2. So divided by log 2, divided by log 2. This part cancels out, turns into 1. So x equals log 3 divided by log 2. That's the exact answer. If we want an approximate answer, we would put that in our calculator. Don't forget to put your parentheses around the 3 before you divide the log 2. And suddenly I'm wondering if I did this right in the calculator, so I'm going to double check it while you're writing, because I'm worried that maybe I didn't put the parentheses when I did this. Divided by log 2. Okay, I did do it right. So I get approximately 1.585. So what this answer is telling us is that 2 to the 1.5 power would give us 3. That's not something we could ever do in our heads. Okay, the next example is a little bit more taxing. Sorry for my microphone issues. Here we go. I'm going to use the same idea here. Just for fun, let's use natural log instead of log base 10. We're still going to get the same result. So we're going to start by taking the log of both sides. So I'll write that down so you know what I'm doing. So natural log of 7, I don't need that parenthesis there, 7 to the x minus x plus 1 power equals the natural log of 3 to the negative 2n power. So now we're going to use the power property. So move that x plus 1 as a coefficient. And the negative 2n as a coefficient on the other side. Then we're going to use the distributive property. Natural log 7 just represents a number. That's a weird decimal. We're just going to write it as natural log 7 to keep it prettier. So we'll have x natural log 7 plus 1 times natural log 7. And then I really didn't need that parenthesis in the first place, just negative 2 times n times natural log 3. Now that shouldn't have been an n from the very get-go. You can see that I wrote this wrong and I don't know why. So let's go in and fix that because it's going to be important that our x's match. So we need to put them together. Okay, so we need to move x terms to one side. And then everything else to the other side. Okay, so this has an x in it, this has an x in it, that does not have an x in it. I could move this over there, but then I'd have lots of negatives. So I think I'd rather move this part over here and move that over there, which is going to turn this negative, but I'm going to have it somewhere. So that'll give me x natural log 7. I'm adding the 2x natural log 3 to both sides. And then I'm going to subtract the natural log 7 from both sides. Now that I have that x on the same side here, I can factor it out. So I factored out the x. And then we're going to divide to get the x by itself. So yes, we're literally going to divide by this entire thing. So x equals negative natural log 7 over natural log 7 plus 2 natural log 3. Now I know some of you are thinking, wait, can I cancel that? No, you cannot because these are adding. This is an entire binomial that's connected together, and so that individual term cannot cancel with that term. So this whole thing has to go in the calculator very carefully with parentheses, and if you do it correctly, you'll get the result negative 0.47. The first time I put it in my calculator, I got the wrong answer because I forgot to put enough parentheses. So for example, you might want to actually do parenthesis around this part, and then divide, and then do parentheses around this part, and that, parentheses around the whole thing. The more parentheses you use, the more chance you have of not making